Okay, recording. Okay. Okay, well, just quickly. Free-body diagram is pretty straightforward. You've got your mass. You've got mg, and I didn't label the mass. The mass is m. You got mg. You've got your applied force. And you've got now your normal force. And you want the normal force to be parallel to the y-axis, so you're going to tilt your axes so that y is here. So here's your normal force. And that's it. But of course, your x-axis is going to have to be perpendicular to the y-axis, which is parallel to the normal force. So you have this. Your applied force can go away. And be replaced by its components, which I would normally label, but we're out of time, so you can label them, okay? So we have this. Now what we see is that, of course, mg inconveniently labeled there. I'd say someday I'll learn to think that ahead, but I don't think it's ever going to happen. Okay, here's mg. So here is one component of mg, and here is another. So we cross out mg as well and replace it with its components. And now we can write equations. If it's in an equilibrium situation, then this plus this has to equal 0, and this has to equal this plus this. Oh yeah, we do have a frictional force too. Sorry. Let me do this. And make these things blue. Here's your frictional force. And it's equal to in magnitude to mu times F norm. And now we can just write our equations for the X components and our Y components, okay? Does that make sense? So the whole thing is, this applied force is adding a downward component to the component of mg, okay? So if you're pushing hard, well, that's going to tend to increase your normal force. The harder you push, the more normal force you're going to have. Because the applied force has a component in the negative y direction. The normal force has to balance everything in the y direction, okay? So you can kind of take that intuitive idea, put it together with your analysis and get a good understanding of that situation. That's not a trivial situation. You want to really understand it, okay? Okay, very good.